In the previous example, we took a look at a problem where there was a variable in the exponent. Specifically, they were asking us how long would it take to double our money. We had to find a value for t. In order to do this, we jumped into this table and we had to scroll down to find approximately how long it would take our money to double. In this case, it took 18 years. There is an algebraic way for finding that value. Instead of building a table and running to the calculator, we have this thing called a logarithm. Logarithm is a pretty scary word, but a logarithm is just another way to write exponents. Algebraically, what we do is we use logarithms to get variables out of the exponent so we can do algebra as normal. So the logarithm has an interesting form. Note that a logarithm is abbreviated log, L-O-G, and then it has a base. That base is the same base you would have in exponential form. So if you have a log base b, well, that's the same as having an exponential with base b. What happens, though, is your inputs and your outputs switch. So b to the x power equals a. So logarithmic functions and exponential functions are inverses. That's a word from the last chapter. Remember when we were finding inverses, how inputs and outputs flip-flop? We were using x's and y's then. But those inputs and outputs switch position. That's exactly what's happening here. A is now on the right side. Over here in logarithmic form, it was on the left side. X, our exponent, is on the left side for exponential form, but it was on the right side for logarithmic form. Inputs and outputs have switched. So the reason we did all that work with inverses is to set us up and get comfortable with logarithms. Now, logarithms can feel complicated at first, so it's important to remember, like, why the heck do we need this new construct? Logarithms are important for answering questions where the variable would have been in the exponent. The big one is, how long to double my money? That question is much quicker to answer with a logarithm than it is with a table, especially if the answer for how long does it take to double is, like 40 or 50 years. I wouldn't want to scroll down that far. Algebraically, answering that question is very quick. We also looked at that world population clock. So a question like how long until Earth or some random environment reaches its carrying capacity, that's also a question you can answer with a logarithm. And then we also have the nuclear case. How long until this nuclear waste is 99% depleted? Because nuclear, probably easier with a picture, radioactive elements have what's called a half-life, a period of time in which they are depleted. So if after one half-life, half as much is left. After two half-lives, there's only a quarter left. So on and so forth. So we can ask questions related to half-life. How long until this really radioactive, this really toxic substance is suddenly safe to be around humans? It actually takes quite a while, quite a few half-lives, before something is decayed to the point where it is no longer threatening to us. So there are really important questions that logarithms can help us answer. So whenever we introduce something new and scary, especially a vocab word like that, it is important to go kind of like, why is this a thing? And those are a few examples of reasons why we use logarithms. So before we do any crazy algebra, let's just take a look at going back and forth between logarithmic and exponential form. We'll go ahead and do that in the next video.